next week. I'll send out a link to this on Sunday as a reminder so that we'll be doing a late start each day next week. Our test it's gonna be split into 2 days. So it's normally just a 2-page test. So we'll just do page 1 on Wednesday, and page 2 on Wednesday. Thursday will be a little bit more extended time than Tuesday, Thursday. The EOCs are longer, so these Tuesday, Friday class periods are going to be only like 20 minutes, 20-ish minutes. Okay. And I don't believe no study hall next week at all. Just yeah, your 4th or 5th period will just be your lunch period. Yeah, question.
So Tuesday and Friday we start at 11:40, and the other days we start at.
That's right. Yeah. 40. So I think all the classes will only be 20 minutes ish. Monday, Tuesday, and Friday, and then Monday, Wednesday, Thursday should be 35 minutes. Yeah. Test will be on Wednesday, Thursday. Yeah. So it's an hour test. Well, it's a full class period, but we'll split up into 2 days. And it was a 2-page test, but we'll do page 1 on Wednesday and page 2 on Thursday. Yeah, I will hold help sessions 4th period on Wednesday and Thursday. So yeah, you want to come in anytime. And I hope to get back your quizzes on Monday. If not Monday, then Tuesday. Okay. All right, we're going to continue with more confidence interval practice. So more of the same from yesterday, but there's going to be some problems that's going to require a little bit more or a little bit different look to it. So we'll take it step by step. So page 27. Okay, have your calculators out. Okay, a town takes a poll of its residents to find out how many people will be willing to pay a new tax. Let me make sure I'm recording. Okay, repair a town sidewalk. Out of 1,100 people polled, only 130 said they would be willing to pay. So that's our sample percentage. In this case, they don't give us a percentage. We have to find that ourselves. We use these two numbers to divide over each other. Sorry, 1,100, not. Okay, 0.118. Okay, here's the formula we'll be using. Okay, and we'll get to you. You'll be given this formula to use on the test. Okay, find a 90% confidence interval. We know we have to use this information to eventually work our way to our z, but it's going to first look like this, right? We always have to do this 1 minus c percentage over 2. So our confidence interval, our confidence percentage is 90%. So convert it to a decimal, 1 minus 0.9. we get 0.05. And now we have to go to our table and find the z-score that's associated with 0.05. So that's a very small number. Page 2 will take care of from 0 to 40% or 0 to 0.4. And then page 3 takes care of 0.5 to 0.9. So 0.05 is going to be closer to the top of page 2. I use negative 1.65. Either one is fine though. Okay, so we found our sample percentage. We have our Z. Any questions so far? Yeah.
Use 1.6.
They're both the same distance away, so I think either one's fine. Yeah, I can use either one. Yeah, if they're the same distance away from the target percentage or target probability, then we can choose either one. So if your answer,
Just see which one we use.
yeah, exactly right. I'll look at which one you use and adjust your work, checking for answers accordingly. Okay, so now we don't have to worry about the negative because the negative is taken care of with a plus or minus. So just put 1.65. Make sure your square root is over the numerator and denominator. Okay, let's figure out this decimal first. So don't worry about the 0.118 plus or minus. Just figure out what that decimal is equal to. Again, make sure you put the entire fraction under the radical. Like this. Okay. Make sure your 1100 is under the square root and not outside the square root. Okay, so this is my margin of error. So it's going to be to the left and to the right of 0.118 by this amount. Okay, so what we're getting at is a percentage, right? So between 10% and between 13% is going to be our interval that will give us 90% confidence interval. So part B says if 15,000 people live in this town, then a 90% confidence interval will be between. So basically we find 10% and 13% of 15,000 people. So we just multiply each of these decimals by 15,000. Okay, we'll just round to the nearest whole number, or we'll round down. Oh, actually round to the nearest whole number. Okay, let's continue working through. These are all kind of similar, but I think we'll see something a little bit different when we get to the bottom of the page, but I think right now it's going to feel the same as our steps from yesterday. Right, company produces white bread, is concerned about the distribution of the amount of sodium in its bread. Company takes simple random sample of 100 slices and computes the sample mean to be 103 milligrams of sodium per slice. So sample of 100 slices, that's my n value. Mean is 103. Standard deviation is 10. Okay, so we're going to use that second formula because we're given information about the mean. Okay, here's the formula we're going to be using. Looks a little bit cleaner than the previous one. Okay, we have to get to the z-score from our 1 minus c over 2. So we'll step off to the side and do that. Find your corresponding z-score. It looks like I can choose between negative 0.57 and negative 2.58. I'll choose 2.58. All right, I think we have everything that we need. Sorry. So. Hey, what does that 99% confidence interval mean? Yeah, that's right. We know that we can say within a 99% confidence that the sodium level is going to be between these two, somewhere between these two intervals. Okay, number 3, you work for a consumer advocate agency, want to find the mean repair cost of a washing machine. Standard deviation is 1750. You randomly select 40 repair costs and find the mean to be $100. Okay, calculate 85% interval for the population mean. Okay, spend the time to figure out the z-score, but first we got to go through this formula, right? One minus confidence percentage divided by 2. Okay, 0.075. Let's find the z-score. 4.
You get the formula.
Yep. Yeah, I'll give you the formulas. Okay, number 4, we're going to be using the same formula as above, but we're going to be given a slightly different piece of information and working backwards from solving for a different variable is going to just make it feel like a different process. So it says you want to estimate the mean fuel efficiency for all Focus cars with 99% confidence and a margin of error of no more than 1 mile per gallon. So here they're telling us what the margin of error is. Okay, so that's basically this part of the formula right there. So your margin of error is going to be the z sigma over root n. So put that to the side here. Margin of error is no more than, so less than or equal to 1 mile per gallon. Sorry, mpg. Okay, let's gather some information and then we can work within this formula here. Okay, we'll come back to that 99% confidence interval. Sigma is 2.4. How large is the sample do you need? So we're looking for n. That's the information that we don't know. Okay. We're also going to find z by going through this 1 minus c over 2. We know that c is 0.99. We have 0.99 that showed up from before, right? So 0.99 gave us a z-score of 2.58. We can use this over again, or we can calculate it on our own. But it's the same confidence interval, so we can use that information from, we already gathered that information. So 1 minus 0.999 divided by 2, we get 0.0005. And we know from our z-score is negative 2.58. So I'm just going to copy that down since we already gathered that information from before. Okay, so margin of error is just this portion to the right of that plus or minus. So let me just write that formula here. Margin of error is equal to z sigma over square root of n. Okay. All right, so we have margin of error being 1, z being negative 2.58, sigma is 2.4, and we just have to algebraically figure out what n is. Okay, so I'm just going to cross multiply and then work our way to solve for n. So cross multiply here. Square root of n equals negative 2.58 times 2.4. .12. Okay, it's negative, but I'm about to square both sides because I want to get from root n to just n. So we're gonna just, so how much sample size do we need? We're gonna have to have greater than or equal to. Okay, of at least 39. Okay, just to round it up to the nearest whole number. Or you can write it out this way. All right, so this is the one that feels a little bit strange because we kind of have to, same formula, but we kind of algebraically kind of work in a different way to get to the variable that's missing.
Wait, so how'd you get, right when you, plugged in the, how'd you get of n squared? Like on the third step, 12, yeah.
Oh, I cross multiplied. I did. So this is really 1/1. So 1 times root n times 2.58 times 2.4.
Oh.
And then I squared both sides.
Gotcha.
Okay, page 28. Okay, so number 5. A and B will feel like something from the previous section. And then when we get to part C, then we're gonna then it's gonna feel like where we got to deal with confidence interval. Okay, but initially it's gonna feel like we're just gonna like a quiz problem. Okay, actual time it takes to cook 10-pound turkey. It's a normal random variable with a mean of 2.8 and standard deviation of 0.24. What's the probability that a randomly selected 10-pound turkey will take less than 3.1 hours? So we're looking for probability of x is less than or equal to 3.1. Okay. Our formula. Okay, gather some information. Okay, find the z-score, and then from the z-score, get to the probability. Okay, z-score 1.25, that's on page 3. .8944. What's the probability that cooking time will be between 2.7 and 2.95 hours? So if we're looking for the probability between two values, we're going to do z-score twice and then just subtract the decimals, the probabilities. Okay, so negative 0.42, page 2. .3372. Find z-score again, coming from that 2.95 hours. Okay, 0.63. .7357. And then we simply subtract the two probabilities to get what we're looking for. Okay, so A and B is kind of review from what you've seen before, and then part C is the new topic there. So find 0.1 on here to get the corresponding z-score. Negative 1.28. Everybody go with part B. Can I scroll up? Okay, number 6. Yep.
That one. And it gives you 95 is a magazine. I subtracted like the decimal, the 0.5. next to that. Yeah.
Oh. Oh, let me see. You're right. I need to, yeah, so this is a little tricky here. 95 is not the number we want. We want the 300 over 395, sorry. So it's giving us 95, we really want the people who have a subscription. So 300 minus 95 is 300, so. Thank you for that catch. I'm gonna change a lot of these numbers here then. Sorry about that. Okay, we'll just finish with 7, but that's going to throw off our p-value a little bit. But our z should still stay the same. 0.75 minus 4. Okay, does everybody see why we changed that from 95 to 300?
It's 95 over
Yeah, we want the percentage of those who bought a subscription. So if 95 of them bought the magazine, then subscription is going to be the other. It's going to be 395 minus 95, which is so. Thanks for that catch. But that's going to throw off our p-value a little bit, so that's why I went back and changed my p-value. Okay, good. Let me check pages 27, 28. Okay, we'll do some more practice Monday, but we can also start our test review. We'll do test review Monday and Tuesday, and a test Wednesday and Thursday.